Hey there and welcome. Ever stop to think about how many ways you can shuffle a playlist, line up for a photo, or even hand out medals in a race? Well, the secret behind all of those things is exactly the same, and it's all about order. Today, we're going to crack the code of arrangements.
Okay, let's jump right in with a little puzzle to get our brains warmed up. So imagine you've got a red ball, a blue ball, and a green ball. You shuffle them under 3 cups. The real question is, how many different ways could those colors line up?
With just 3 things, we can actually solve this the old-fashioned way, just by listing out every single possibility. So let's start with red in the first spot. You could have red, blue, green, or you could have red, green, blue, right? Then we just do the same thing for blue, and then again for green. And once you've written them all down, red, blue, green, blue, blue, red, green, red, and so on, you just count them up. And the answer is 6. There are exactly 6 possible ways to arrange those 3 balls.
That was pretty easy, right? But what happens when we crank up the difficulty just a little bit? Forget 3 balls. What if we had, say, 5 different books to arrange on a single shelf? Are we still going to try and list out every single option?
Well, you could give it a shot, but you'd be sitting there for a long time because arranging just 5 items gives you 120 different possibilities. Yeah, our little let's just list them all method, it completely falls apart. We clearly need a better way, a shortcut. And lucky for us, math has the perfect tool for the job. It's called the Factorial. And the symbol for it is super simple. It's just an exclamation point. So when you see a number like n with an exclamation mark after it, all it means is you multiply that number by every whole number below it all the way down to 1.
And this is where you really see how powerful that little exclamation point is. For our 5 books, you could do it the long way. You've got 5 choices for the first spot on the shelf, then 4 choices for the second, then 3, and so on. Or you can just write 5 factorial. Same calculation, same answer, 120, but way, way cleaner.
So there's actually a name for what we've been doing. It's called a permutation. And that's really just a fancy math word for any arrangement where the order really, really matters. The big idea here is that for any number of different things, let's call it n, the total number of ways you can arrange them is just n factorial. It's as simple as that.
Okay, but things get even more interesting when we don't have to arrange all of the items. What if you're just picking a few from a larger group, but the order you pick them in still matters? Here's a perfect example. How many ways can you pick 4 swimmers for a relay race when you have a whole team of 12 to choose from?
We can actually use the exact same logic we used before. Just think it through. For the first leg of the race, the coach has all 12 swimmers available. Once that person is picked, how many are left for the second leg? 11. Then for the third, there are 10 swimmers left, and for that final anchor position, there are 9 choices. So what do? We just multiply those choices together. 12 times 11 times 10 times 9. And we get a number that's probably bigger than you'd expect. 11,880. That is a lot of different potential relay teams you can make from just a dozen swimmers. And of course, there's a neat formula that does all this heavy lifting for you. It's the official permutation formula, and it's designed for exactly this kind of situation. It calculates the number of arrangements when you're choosing our items, in our case 4 swimmers, from a bigger set of n items, our 12 team members. It's n factorial divided by n minus r factorial. It does the exact same math we just did by hand.
Now, at this point, you might be thinking, okay, this is a cool math trick, but what's the point? The truth is, once you know what to look for, you start seeing permutations absolutely everywhere. This isn't just for a math class. This stuff is all over the real world.
Think about it. Awarding gold, silver, and bronze medals. The order is everything, right? Gold is not the same as bronze. Or what about assigning ad slots during a big TV show? The first ad is way different from the last. Creating a batting order for a baseball team, electing a president, VP, and secretary for a club, or even just lining up your friends for a group photo. In all these cases, the specific order is what counts. And just to show you how astronomically big these numbers can get, let's consider one last problem. Imagine a salesperson has to visit 15 different offices this week. In how many different ways, how many different routes could they get that done?
Well, the answer is simply 15 factorial, and that number is over 1.3 trillion. I mean, that's a number so huge it's hard for our brains to even comprehend. To put that in perspective, if you tried a new route every single second, it would take you over 41,000 years to try them all. That's just mind-boggling.
So, what's the key takeaway from all this? It's really simple.
From arranging 3 colored balls to planning a sales route with over 1 trillion options, the one common thread is that the specific order, the sequence, is absolutely crucial. When order matters, you're dealing with permutations. And that brings us to one last big question to chew on. We've seen how important order can be. But what about all those times when it isn't? What if you're just picking 3 friends to go to the movies with you and it doesn't matter who you asked first? What happens then? Well, that's a question for another time.